Alright, and welcome to the last unit of work both remotely and the last unit of work that we'll do at school as well. So it's called Functions and Relations, and today we'll explore functions and relations. So the graph of the linear relation y equals 2x take 1 appears below. So note we've got a y-intercept of -1, so there's when x is 0, y is -1, and a gradient of 2 as x increases by 1, the y values go up by 2. All right, all checks out. The equation y equals 2x take 1 describes a relationship between x and y. Okay, so it's a relationship here that y values are obtained by substituting values of x, and x values are obtained by substituting values for y. So you may have heard me or your other maths teachers over the years talk about this as a linear function. Okay, so we can call this a linear function or a linear relation, but you guys actually don't know what a function is just yet. So it's our job today to talk about what a function actually is. So a relation that has only one y value for each of its x values is called a function. All right. That's basically the rule. Well, it is the rule. Has only one y value for each of its x values. All right, so let's just have a look at this linear relation here. This value here is x is equal to 5, and what's its y value? It's 9. At x is equal to, what's that, 2? The y value is 3. Okay, and what we note is that for each of the values of x, I get a maximum of one y value. Okay, and that's called a function. Just made the point here, all functions are relations, but not all relations are functions. So there's some relations, this is an example of a linear relation that is a function. That's a function for sure. And in fact, every single relation that we've looked at this year is a function also. So the ones that we've looked at in Year 10 are all functions, but I'll show you a couple that aren't. So this function is a relation. Okay, this is y equals 2 to the x, or an exponential function. So it's a relationship between x and y. So again, you can give it x values and it gives you y, or you can state a value for y and it gives you x values. Okay, so this is a relationship between x and y, but it's also a function because if you look at it, every x value produces a maximum of one y value. Right, this relation is not a function. Why? Well, it is a relationship. Give it values of x, all right, and what it will do is you can get y from that, or vice versa. Give it y values and you can solve for x. Okay, so it's a relationship between x and y, but it's not a function. Now the reason it's not a function is when I use x is equal to 5, what it produces is this y value and this y value, and that's a problem. Functions only ever produce one y value for each x value. Once it produces 2, it gets a little confusing. Which one's the value that comes out of the function? Okay, so this one here, we call this a relation, but it is not a function. Right, the vertical line test is a way to determine if a relation is a function, and it sounds more technical than it is. All you do is you draw a vertical line through a graphed relation. If you intersect with the graph more than once, the relation is not a function. So here is the graph of it's called the love equation. Is it a function? So here it is. That's what I graphed to produce that. And all I do is I don't even have to use a ruler. I was going to say grab a ruler, but you can just do it with a pen or pencil, or you can do it visually. You just draw a vertical line. And notice with my vertical line, what I do is I hit a y value there and a y value there, i.e. I've hit more than one y val, therefore it is not a function. Function. All right, so it is not a function because we've got more than one y value for one x. Okay, here x produces this value here and this value here, and functions don't do that. Functions only produce a maximum of one y value for any given value of x. Now you might be thinking at this point, I don't know whether you are, but functions, like who cares? What does it matter if it's a relation or a function? And it's a good question at this stage. The majority of the Units 1 to 4 methods course deal with mathematical techniques that can only be implemented or done with functions. Thus, knowing how to spot one is important. Okay, so what we'll be doing in the next couple of years will be operating with functions. Okay, so we need to know what one is. Now, there's a particular notation called function notation, funnily enough, that we can use when we're talking about a function. So once we know that our relation is a function, we can use that particular notation. So consider the relation y equals 2x take 1 again. We know it's a function. We've explored it. We looked at it. There it is. For any value of x, we only get a maximum of one y value. Or if I drew vertical lines all the way through there, I'm only ever going to hit a maximum of one y value, i.e. passes the vertical line test. So once I know it's a function, that's good, and I can start to use function notation. So the y value we obtain is said to be a function of the x value. So what you get is a function of what goes into the function itself, or a function of the x value. So we say that the y value is or is equal to a function of the x value, where this thing here, we call this, or we say that is read as f of x, okay, f of x. So when reading f of x, what we say is f, this part here is the name of our function. We call it something, f, g, h, I, k, p, all right? All of them, or functions can be named different things. And x is the input value. So we say that f is a function and x is what's being inputted, okay? So remember, fundamentally, what we want to think about is y is a function of x. That's a really important part of the whole idea. So we can now rewrite y equals 2x take 1 in function notation. What we can do is change that y and replace it with the f of x notation. So we can say that this is a relation, y equals 2x take 1, but written as a function, it's f of x equals 2x take 1. So what we've done is written it using function notation. Now again, you might think, well, I was pretty happy with the original notation. All it does is it looks more complicated. But function notation is exceptionally easy to use, and it's slick, it's pretty, it's aesthetically beautiful. All right, maybe beautiful is going a bit too far, but I'll try to show you the difference. Okay, so what we've got here is this function, but it's written with a y equals, or in y equals form, and this, the same function written in function notation. So what we want to do is find y when x is equal to 2. Now, how would I describe that process if I was doing that? What I would do is I'd say sub x equals 2 into y equals 2x take 1. And then I'd go ahead and do it. Y equals 2 times 2 take 1. Y equals 4 take 1, which is 3. Now, how do I do it with function notation? Well, it is dead set easy. All right, so what I would do is simply write f of 2. What that means is f is a function, and I want to input 2 into the function. This is basically saying insert 2 into the function, or I often say drop 2 into the function. And that means that everywhere where I see an x, what I'm going to do is replace it with a 2. So this is 2 times 2 take 1, which is equal to 3. So notice that this sort of stuff that we have to do to explain where and what we're substituting just is so easy to do with function notation. Find x when y is equal to 3. So we're going to say sub sub y equals 3 into y equals 2x take 1. That's what we'd have to do. So we'd write 3 equals 2x take 1, 4 equals 2x, x equals 2. All right, for function notation, we can write my function f of x equals whatever the value is, f of x equals 3. 3 equals 2x take 1. So all I'm doing is replacing f of x with the number 3, right? And then solving 4 equals 2x, x equals 2. Right, so exactly the same number of lines here, but we don't have to worry about sort of explaining what I'm substituting into what. Okay, functions and relations have what we call a domain and a range. The domain is the set of values a function can accept, and they're the x values it's willing to take on. The range is the set of values a function can produce or output. So what y values can I produce? We've used set notation, but I'm going to show you some interval notation. It's much easier. Again, when we introduce function and interval notation, things get a lot more slick. All right, so consider the relation y equals x take 2. Now it's a parabola, and that parabola has moved 2 units to the right. So our typical parabola has a turning point at 0, 0. This one is going to turn at 2, 0. Y-intercept when x is equal to 0, 0 equals a 0 take 2, that's going to be 4. And just using symmetry there as well, let's draw our parabola. E. Not all that symmetrical. Anyway, we'll run with that at the moment. When x is equal to 0, y is equal to 4. Why is the function a relation? Explain. All right, well, if you look at it, it passes the vertical line test, or we'll say for each value of x, it produces only one y value. Write the relation in function notation. Okay, sure. All I'm going to do is note that y is a function of x. So this y value is a function of the x value used. So I can simply replace y with f of x. Now I'm going to call this one a different name to the other one just to sort of be a bit different. So I'm going to call this g of x equals x take 2 squared. All right, so I'm just going to call it a different name than this one here, f of x, because it is different. What's the domain of the function? These are the values that the function will accept. And notice here that this is a parabola, right? So let's think about it. If I put x in, it produces a y value. If I put this x value in, it produces a y value. If I produce or put this value 5 in, it produces a y value. And it will keep doing that. I know I haven't continued this, but if I continued it on, it would produce a value. So this actually, we describe this next year as the set of all real numbers, okay? But the way we're going to describe it this year is in interval notation. We're going to say that the x values are an element, okay? So this is a bit of notation here. So this thing here, you write it like a C with a line across the middle, element. And then what we do is we put an interval of values that will be accepted, all right? Now, what we do is we are going to curve circle this and say negative, infinity, comma, positive, infinity. Now, this 8 on the side is the infinity symbol. And this basically says x can be any number from negative infinity all the way to positive infinity. All right? Now, note that these curved brackets here mean not included, and this square bracket means included. And I'll explain what I mean in a sec by that. So what is the range of the function? This is what the function can send out. These are the values that can possibly be produced. So all you do basically is you imagine sort of coming along and looking at the function. And what you do is you start looking down and you start looking up until you note the lowest value that can come out of the function. This is the lowest y value that can come out. All right, and this is what your starting point for the range. So we say that y is an element. These are the numbers that can come out. So the lowest value is 0. Now note that I can produce that value. 0 can come out. So what I'm going to do is square bracket and include 0. Now 0 can come out, and then I keep looking up until I find the last number. Now that's going to be difficult to do here because the last number is all the way over to positive infinity. And we curved bracket that. Now why curved bracket? Well, we can't square bracket it because we can't include positive infinity, because what is positive infinity? Right? What number is positive infinity to include it? Infinity is a concept that basically means it just keeps going and going and going and going. So curved means we're not going to include the value of infinity itself because no one's actually cracked infinity and found it. So what we're going to do is say that it is 0 inclusive all the way up to positive infinity. That's our range of y values that we can produce. Right, so some applications. If f of x equals this, find f of 0. So that basically is saying drop 0 into the function. So everywhere where you see an x, replace it with a 0. Okay, and that would be the equivalent move of if I had x squared take 3x take 1, what I would do is say sub x equals 0 into that. Right, so this is the equivalent move. So that's 0 squared, take away 3 times 0 is 0, take away 4, which is negative 4. Right, f of negative 2 means instead of putting 0 into the function, can you drop negative 2 in? And don't forget to include some brackets when you substitute. Negative 2 times negative 3 is positive 6, take 4. Right, negative 2 all squared is 4 plus 6, take 4, which is 6. F of a simply means wherever you see an x, change it to an a. A squared take 3a take 4. Nothing else needs to be done. F of x equals 0. Now this means something different to this. What this means is, can you please replace f of x equals 0? F of x equals with 0. So what we're going to do is do that. 0 equals, so I'm just replacing f of x with a 0. Okay, and although it doesn't say it, what we're going to do is solve. So let's add a little bit to the question here. We're going to say f of x equals 0 and solve for x. All right, so basically what this is, or what we're doing here is this move here would be getting the x-intercepts. All right, so 0 equals 4, 1, negative x, x take 4, x plus 1, x is equal to 4, x is equal to negative 1. Okay, so f of x, or the y value, is equal to 0 when x is equal to 4, x is equal to negative 1. Is the following a function? And all they've done is given us a list of ordered pairs. I don't know. Let's graph them. Here is 1, 4, 2, 8. Right, I'm not really going to do this to scale. 4, 3, 1, and 5. All right, is it a function? Well, remember the definition of a function. For any given value of x, it can only produce one y value. Now the problem is, if I declare this a function, if I do f of 1, this will give me two things. It'll give me 4, or it'll give me 5. And which one is going to come out of the function? Okay, functions only produce one outcome. This is attempting to produce two. So we're not going to allow that, okay? We're going to say that this is not a function, okay? So not a function as when x is 1, y is 4, and when x is 1, y is 5. Now this is allowed. It's allowed to, it's a relationship. It's a relation. This is allowed to happen, but we just can't call it a function. All right, this one here. So we've got those coordinates, so 3, 5, 4, 5, 5, 5, 6, 6. All right, so let's have a look at this. Now, this x value produces the y value 5. 4 produces the y value 5. Now, 5 gets produced a lot, but that doesn't really matter. The trick is, and all we want to think about is, for any given value of x, does it produce a maximum of one y value only? Okay, and in this case, yes, it does. So it is a function. So the difference here is, note that this x value here produced two y values. No instance or at no time does that happen for this particular relation. So yep, we've got a function there. All right, and then the last question. If f of x equals root x plus 1 over x take 2, state the domain of f of x. Note, you will not need to graph this function. And to be honest, I don't even have a clue what the function actually looks like. All right, so what am I allowed to put into this function? So if I was doing f of something, what could I actually put in? Well, the first thing to note is that when we square root something, we're only allowed to put in positive numbers or 0. So we know that x has to be greater than or equal to 0. That's for sure. All right, so if I try to put in f of negative 2, that causes a problem with this function. It will buck. I suppose it's like trying to put a 50-cent coin into a machine that only takes $2 coins. Something is going to go wrong. It's not going to let you do it. So that's what this one's going to do. It's going to go, no. Okay, so here is one aspect of the domain. It's when x is greater than or equal to 0. But there's something else here as well. Okay, and if I ask you what 1 divided by 0 is, hopefully you remember that that is mathematically, it just doesn't make sense. We can't do 1 divided by 0. Okay, now over here we've got 1 over x take 2. And can you think of a number for x that will cause a divide by 0 error? Well, the answer is going to be x is equal to 2. If x is equal to 2, what will happen is we're going to get a divide by 0 error, and that's a problem as well. Right, so the way we're going to say this, it's going to be a little complicated, but we're going to say that x is an element of. Now we're going to take all the values from 0 up to, but not including 2. Okay, so we're going to allow this function to accept values from 0 all the way up to, but I'm not going to let you put 2 in itself. Okay, we're not going to include the 2, because that will make this or cause this to have a divide by 0 error. But we now can actually continue values after 2. So what we do is we put a union symbol there saying, I'm going to put another set of numbers or another interval here afterwards. Union with 2, okay, so this basically says 0 up to but not including 2, and from 2 but not including 2 itself up to. And now we go back to this definition here, which is greater than or equal to 0. So we can actually take values all the way up to positive infinity, not including positive infinity, because that's not really a number, it's just a concept. Right, so that's where this function would be true. Right, if you want to hang around, I'll quickly graph that function so we can see it. And you might get an idea of how the function is going to behave. But if you want to actually get started on your work, feel free not to watch this. Okay, so f of x equals square root x plus 1 over x take 2. All right, so there's my function. And you can see what it's doing here. It's producing y values for x equals 0. But then what it does at either end of x equals 2 is it'll get extremely close to it, and we're going to see this happen when we do hyperbolas in about a week and a half's time, but it actually can't give us the value. So there's what our function actually looks like. Okay, so yeah, pretty cool function. Right, so there's your work there, 7H. Get through that.